Hi everyone, it's time for another video, and in this one we're going to talk about how we can view the logarithm as the inverse of the exponential function. And we'll see, what does that mean and what properties do we get from that, knowing that the logarithm is the inverse of the exponential function. So what I have in front of us are two functions. So the first one is the logarithm that we talked about in our previous video. So we have a log base b of x, right? So this is our function. And when we put in an input x, what the logarithm is giving us, right? This is the exponent that I have to put on top of b to get x back as a result. And this function over here, right? We have our function b to the x, which is saying, right, if I put an input into this, we'll take the number b and we'll raise it to whatever input we decide to have. And so with inverse functions, what we've become familiar with is the inverse is something that undoes what the other function. So inverse pairs are things like multiplication and division. So if I want to undo multiplication, I would divide, or addition and subtraction. If I want to undo addition, I would subtract. The same relationship happens here. If I want to undo this exponentiation, what I would say is I can use the logarithm for that. So they undo each other. All right, so in order to see that, if two functions undo each other, what we do is we compose them. So what we're going to do is we're going to look at the function composition. So we're going to look at f of g of x. And so in this case, what I have for function composition is my inside function is this g of x, and my outside function is log base b. Right, so what I'm essentially doing is I'm going to take this function and I'm going to plug it in to the logarithm. And what we get here is we get log base b of b to the x. Okay, so for this part of this video, we're going to be interested in exploring what does this give us. Right, so what does this happen? What happens with this right here, log base b of b to the x? And then we're also going to be interested in doing the composition the other way. So we're going to look at g of f of x. Okay, so our outside function in this case is going to be b to the x, and then I'm going to plug in the logarithm. So I'm going to get b to the log base b of x. Okay. So let's start with the one on the left. Let's look at this composition. And I'm really not particularly interested in this f of g of x over on the left. What I am interested in is this log base b. And in particular, I want to know what is it equal to. Right? So if it's equal to some y, what does that mean? What would y have to be? Now, if we think about our snail, if I set this up, b, what this is asking me is b to what power is equal to b to the x. Okay, so if I snail this, b to some power y is equal to b to the x. Right, so let's write that out. b, right, to some power y is going to be equal to b to the x. So if we think about this for a second, we would say to ourselves, well, b to some power gives me b to the x. Well, that has to be x. Okay, so this power that has to go in for y, well, it's going to be whatever x is. And if I write that all down, what this is telling me is log base b of b to the x is equal to x. Okay, and so this is one of the properties that we have for logarithms and exponential functions. And so when we say one function undoes the other one, what we see here is if I had an input of x, whatever I input into the function composition, I would get the same output. So b to the x does something to it, the logarithm undoes that, and then your input remains unchanged. So log base b of b to the x is equal to x. All right. So let's go ahead and let's see the other side of this. So we have b raised to the log base b of x. Now, for this one, I just want to think about what is a logarithm. Right? So if I think about what is log base b of x, well, it's the exponent. Okay, so this is an exponent, log base b of x. And in particular, it's the power that I have to put on b to get back a result of x. And so if we think about this, I have this b right here, and I'm raising it to a power. And the power that I'm raising it to is the one that will give me back a result of x. Right, so if we think about what the logarithm is, it's the exponent you have to put on top of b to get back x. Well, and that's exactly what's happening here. So I'm taking b and I'm raising it to the power. That's going to give me back a result of x. Right, so b to the log base b of x, well, that's just going to be equal to x. So based on the definition of logarithm here. So I know that there wasn't a whole lot of work that we did there, but if you think about it conceptually, and it might help you to go back and actually think about what the definition of logarithm is. Right, so I've said it a few times. I'll say it once more. Right, this is the exponent. We see it's in the exponent here that I have to put on top of b to get back a result of x. Okay, and so that gives me my second property here. Okay, so when we talk about logarithms as the inverse of exponential functions, we get these two properties that are in the boxes. Okay. So what I'm going to do is I'm going to clean this up as I usually do, and we'll come back and we'll see some specific examples. All right, and we are back. So what I've done here is I've given us some examples to think about that are similar to the two properties that we've seen and have particular numbers in them. So what we might see along our way when we're trying to use logarithms is we might see an expression that looks like this. And so we have log base 2 of 2 to the 17th. And so when I break this down, what I want to observe is that the base of the logarithm, base 2, is the same as the base of the exponential function that's on the inside. And so using this property up here, if I have log base b and b to the x, what they're doing is they undo each other, and you're just left with the exponent, this input right here. So if I see a term that looks like this, log base 2 of 2 to the 17th, what I know is that this just ends up being 17 because the logarithm and the exponential function, they cancel each other out, and you're just left with 17. Okay, so the other way that we might see this is we might see something that looks like this over here. So we have 5 raised to the exponent log base 5 of 12. And so if we combine them in the other order, we see that the exponential function, the base is 5, and my logarithm up here has base 5. And so I know that these are inverses of one another, so they're going to end up canceling each other out. And the only thing that will be left over is this 12. So I know that 5 to the log base 5 of 12 is just equal to 12. Okay, so this process of inverse, so undoing one function, is very important when we're trying to solve exponential and logarithmic equations. So just like we would solve a linear equation or we would solve a quadratic equation, we're using these inverse properties to undo what we've done in order to get a solution. So this is going to come back and we're going to see a lot of equations that look like this. Right? So these properties right here and this property right here will be very important to us in the future. So as always, I hope this video helped, and I'll see you next time.